Hello everyone, welcome back. Since the last time I checked in here, this has been a crazy busy few days. As you probably know, I just released my latest book, my first one in English, Geospatial Data Science Essentials, which you can see here in the background, and you can also see here, this is how it looks like in a digital format, and you have probably seen it in numerous posts on my social media feeds as well. So for everybody who already has a copy, thank you very much for purchasing the book. And for everybody sending me messages, comments, reviews about the book, also huge thanks. These supporting messages mean a lot to me. So, I've been just sitting over my phone for hours and was reading and replying to all the comments and messages. And this is just really, gets me motivated and helps me to push myself towards creating a lot more tutorials, better code, and just keep the things rolling. So thanks again for the support, and now let's see what I have here for today. So over the weekend, I shared a list of tutorial exercises on Substack, namely 5 geospatial data science tasks, which now I'm going to show you how to quickly solve using Python and all the usual stuff and usual stack I've been using here. So let me just zoom in very quickly and start to solve these challenges right here, right now. All right, welcome back. Here we are at my usual Python terminal. But before jumping into the coding part, I have one more announcement to make. Actually, 2 announcements, which I just forgot to mention in the intro part. Next week, on Wednesday, I'm going to do an Ask Me Anything webinar where you can ask me anything about career options, career choices, how to get started in geospatial data science, how to get started in data science, and anything else related. And I'm also opening the floor for questions about the book. Could it be behind the scenes stuff, like how did I self-publish the book, or anything about the technical parts, so what's in the book, how should you use the book, how should you get started to use the book, and so on and so forth. So if you have any questions, join me on the webinar on Wednesday. And if you want to learn about geospatial data science and raster data in great details, then also join my workshop next Thursday, because I'm doing a live workshop, which is going to be about 2 hours, where I'm going to dive into the depth of raster data with Python. So that's it for the promotion, and now let's just start the coding. Yeah, so I also have to put a disclaimer here. I couldn't really rest and sleep enough after the book launch, so please allow me to be a little bit, less coherent than usual, but I wanted to keep the new stuff coming. So here's the new video. Let me just restart my notebook. Maybe I also have to refresh it because, for some reason, Jupyter was collapsing my code cells. That happens sometimes. I guess that's the pro of having free software, it's full of bugs. Okay, so the first question, circumference and area. Create 2 simple geometries, a circle with a radius of 10 and an origin of 0, and a triangle defined by the points 5, 0, 15, 10, and minus 8, 4. What is the circumference and the area of the 2 objects separately and when merged into their union? So, first we will need Shapely. And from there we will need a point and polygon. Let's create the circle first, create a point, and do a buffer around it. We can also display the circle. We need the buffer distance, which is 10. And then create a triangle, which is a polygon, so we need a polygon constructor, and then a list of coordinate pairs 5, 0, 15, 10, minus 4, 8. And now we can print the area of these 2 guys. And now create a union object, that's called union, and then triangle.union. So now we are taking the union of these 2 geometries. As you can see, it has a weird shape, which has a total area of somewhat smaller than the sum of the previous two areas. If we just take the sum, you can see that there is an overlapping part between the two geometries somewhere here. Also, yep, as you can see, the total is almost 400, while the union's area is around 331. Let me just zoom in a little bit, maybe you can see it better. Yes, maybe this will be better. Okay, now something happened. Zoom in again. Yes. Okay, so a smiling face. I think that we have done something similar before, but we like to repeat things because, you know, there was this saying that repetition is like the mother of knowledge. So from Shapely we import line string as well. I think that we will need it. And then create a head, which will be a circle very similar to the previous one. Again, we need a buffering range. Then we need eyes. Let's say it's at the -4 point. And we need the right eye as well, which is at the 4 point. They are regular circles. Here we cannot see the scale, but sooner when we create the union, we will see the scale as well. Then we create a polygon, which will be the nose. And yes, I am reading these from my notes. I cannot improvise this well in Python, so I probably can't draw a smiling face so simply. And yeah, here comes the smiling part. And yeah, so I asked ChatGPT to give me a set of coordinates which will create this, let's say, curved parabola line. So a smile, but for some reason ChatGPT messed it up and created this like sad face, which is really not what I was looking for. So I need to flip this around, and I will create a new coordinates variable, a list. Let's call it corrected. And we will need to, on the one hand, swap the sign of the y coordinate, so we flip it around so it will be smiling, and we also have to shift it so that it's positioned well. So now we should have a proper smile, you know, like the ones in the toothpaste commercials. Yes, there it is. And now let's create the final head, which should be the combination of all the geometries we just created. Now I will carve out the different components of the head from the head itself. Let's see, now we should have a face with two eyes. Okay, now let's also add the nose and also add the smile. And there we are. Looks like me, right? So that's how easily we can create a smiling face in Shapely. And I admit that this doesn't really have any practical importance in the sense that we very rarely create smiling faces in geospatial objects and projects, but knowing how to manipulate geometries can be very helpful if you have to manually tweak or change or update any geospatial dataset or data record. So that's it for task 2, and let's see task number 3, NYC boroughs. So now we are moving from these like toy models to the real world examples. So here as task number 3 says, use one of the built-in datasets of GeoPandas nybb. This data file contains the polygons of each borough in New York City. How many boroughs are there? Compute the area of each borough in square kilometers. Make sure you are using the right local CRS. Create a simple plot using the built-in GeoPandas plotter and color each borough based on its area. Okay, so first let me ignore all warnings. The reason is that I'm not using the latest version of GeoPandas in this environment. So if I just import GeoPandas, I will get many warnings that it's outdated, and I don't want that here. So the version I have installed on this workspace is 0.13.2, and the reason I'm using this older version is that on the one hand, it's just way too deeply rooted in so many projects of mine that it will be a huge challenge or task to update everything. I have to do that sooner or later, but for now I'm voting for later than sooner. But anyways, on my channel you will find the total installation guide for the latest version of GeoPandas as well. But what I like about these older GeoPandas versions is that they come with a bunch of built-in datasets from which we can list the ones available here. And here's the one called nybb. So now let's read this dataset. We use the GPD read file method for that. And then for this we will need to get the path of the built-in dataset. This should be GDF because now I renamed GeoPandas, which is not a smart move. So let's just call it GDF, not GPD. And see, this is how the data frame looks like. We can conclude that there are 5 boroughs in New York City. And now let's compute the area. Oh wait, we already have a column called area, so that's great, but let's also compute it and let's see what happens. Let's call it area 2. I just use this list comprehension to compute the areas because I like list comprehensions. And see, now we have the areas here computed matching the ones in the shape area column. However, the trick is that once we plot the CRS of this geodata frame, we will learn that this one called EPSG 2263 is measured in US survey foot. So now if we want to have results in square meters, then we will need to have this geodata frame in a new CRS system. And I will do a more detailed video about that, but for now, I just show you how the EPSG.io website works and how we can search for a new CRS fitting our, more or less fitting our needs here. So here, EPSG 32118, for instance. Okay, here we can see the 2263, which is in US feet. Let's see what we have here on Long Island. It's hopefully close enough. And we should see the unit of measure somewhere here. I don't see it yet, but maybe if we search for, okay, no, this is per meter. Okay, seems that it's in meters. Okay, it looks like this will do it. So let's just call it GDF2. GDF2 equals GDF2 CRS. And let's see what we have here. Okay, it's in meters. That's great. We did well. Okay, now let's compute the areas in square meters. And here you can see that the area values are roughly a magnitude smaller than the previous ones measured in feet, which is kind of checks out with the differences between meters and US survey feet. So now we computed the areas in, okay, it's in square meters, but we can leave it as it is for now, just a quick division to get them into square meters from square kilometers from square meters. And now create a simple plot. There we just call the plotting function, and we use the column area 2 for coloring. We can set the color map, for instance, to reds, and there we are. Challenge solved. Great. Okay, so now we are moving on to visualize the network of Manhattan. And to visualize and download road networks, we will use the library called OSMnx. which is a combination of OpenStreetMap data and the graph analytics library NetworkX, and is usually called OX. So we will need OX or OSMnx, and we also need a polygon that's enclosing Manhattan. So let's see what we have in the GDF data frame containing the boroughs of New York City. Okay, we have one here, that's Manhattan, that's great. Let's call it admin. And let's also plot it. Okay, so that's Manhattan, that's clear, that's really great. One thing we need to do is to turn it into the long-let coordinate system, which is EPSG 4326, because that's the way we can query data from OpenStreetMap using OX. And for that we will use the graph from polygon method and extract the polygon of Manhattan. And let's call this resulting graph G. It might take a few seconds to download this, but then we can quickly plot the number of nodes and the number of edges in the road network of Manhattan. So back to the task, which I just forgot to read out loud. So visualize the network of Manhattan, execute the following tasks, extract the admin boundaries of Manhattan from the built-in NYC borough dataset. Okay, check. Use the OSMnx to query library to query Manhattan's road network and measure the number of nodes and edges in that network. Okay, this is currently running. And then create a visualization of the network in a figure size of 20 times 20 inches using Matplotlib. Experiment with line width to make it a nice visual. Okay, so here we have the graph. Okay, we have loads of nodes and links, about 50k nodes and 150k edges. So now let's import Matplotlib. And specify the size of the image. I will use 10 inches instead, 20 might be a bit too much for this screen. And to make it run quicker, I will first just pick a small sample of the edges data frame. First we have to create the edges data frame. So we can map a graph downloaded from OSMnx into edges and nodes stored in GeoPandas data frames using the graph to GDF's command. And here the length of the nodes table should match the number of nodes here, and the number of records in the edge table should match the number of edges here. And they do match them, so that's great. Perfect. So now we are moving on to create a plot. Here, as you can see, we import Matplotlib, then create our figure with a given canvas size, and let's plot it here. Let's use black as an edge color, and let's set a line width of 3, and let's switch off the axis. Edges, not edge. Okay, and we have to specify that we want to plot this on the axis. So now this is how it looks like if we have just a few samples. If we have more samples, then it will take a little longer. We should probably decrease the line width. Yeah, so now it starts to look like Manhattan, but it's very, very fragmented. So let's try to plot the whole thing. It might take some time, but until then I will read out loud the next exercise. So while Manhattan is being processed and visualized, the next one is, oh, it's here. Okay, looks nice, but could be better with a much thinner line width. Okay, let's see how it works. Almost there. And then we will, okay, that's getting better. Okay, so for now I will leave it to you to experiment with it, and also let me know if you create your own version of either Manhattan or any other boroughs or cities. I would love to see your visualizations and coloring. And for now we are moving on to the last exercise, which is mapping a small town's center. So here I will use an example from Hungary, a small town called Siklós. I will share the Wikipedia page for it as well. It's a nice town. It has a nice castle, and it's in the south of the country. And we can also find it on OpenStreetMap. So here, that's the admin boundaries of the city. You can see here that's the central part, and here it also has like a smaller suburban part, but I mean the whole place is a suburb because it's a town of about 10,000 people. And then the things we will do here is that we will query the city's admin boundaries using OSMnx, and then we will get the city's center coordinates from OpenStreetMap or even Google Maps, and then we will create a line with a certain given radius around the centering point. Then we will visualize the city's admin boundaries and the circle with a radius of, for instance, 1 kilometers. And we will make sure that the circle has no color fill, but a red thick edge line. And finally, I will also add the basemap using context.txt. So let's get started. We will need an admin variable, which we can quickly get from OpenStreetMap using this quick command. It's a small place, so the query is very fast. Then the center, it's going to be a point, and I'm just checking my notes up there. Yes, let's turn this center point into a geodata frame and call the only column geometry. Let's set its CRS to long lat, and let's see how it looks like. Okay. So the exercise asks us to do things in kilometers. So now we have to turn everything to the local coordinate system, which is EPSG 23700 in Hungary. So let's transform everything into the local system. And now that we did the transformation, we can also buffer this with a 1 kilometer radius and see how the transformation went. Okay, so this looks like a proper circle with a radius of 1 kilometer. Great. Okay, let's get the road network here. Again, using the graph from polygon command, and we will need to get sorry, what was the next task? Okay, first just a regular visualization. Look how I really had to get some sleep, so I almost forget what my own exercise was. So we will need context.txt to have a base map. Subplots. Let's create a canvas, and then we will plot the local admin area first. We don't need any coloring there. Let's use black edge color and the line width of 3, and then also plot the circle. It should be red if I remember correctly. Yes. Okay. And now we will need to add the base map. It has a pretty long comment, so let me just copy it for now. So CTX at base map, we have to specify the axis, the transparency, the coordinate reference system, and the base map provider. And now this should show, yeah. We shouldn't switch the axis off for that. Yes, so now you can see that maybe the contrast is not the best, but never mind. For now, this is just an exercise, but we can also experiment with this. Let's see what happens if we pick another basement provider. or just a basemap type. Let's pick the Voyager one. Yes, so there is Siklos. Great. Okay, and finally, let's just get the road network here. Again, graph from Polygon. We need to transform it back to long lot and then take the geometry. This should be quick because, again, this place is relatively small. Yeah, just a few hundred nodes and edges. And we can plot it using the usual commands. I will plot this in the local CRS again. Let's use line width 1 and see how it looks like. And I will also add the red circle so that we mark the boundaries of the edges properly. Oh, look at that. Ah, yes, it's Manhattan because I forgot to create the edges and nodes tables. So nodes edges equals OX. And let's see what was the command. Here, graph to GDFS. Yes, that's it. Okay, so almost there. Yes, so there we are. Let's switch the axis off and let's use black coloring and thicker lines. Yes, so that's it. So that's the center of Siklos and the road network of it, just restricted to this red circle. And let's see if we have anything else. I think that I have here like a list of additional tasks that you should try and check. But for now that we are already probably over time, and this is probably by far the longest video I created, I would like to stop here and just let you finish the exercises and practice them. So, yeah, so that was my microphone checking out, the other one. So once again, let me just quickly wrap up what I did here. So there were these 5 exercises relying on all sorts of tips and tricks from geospatial data science. And I shared the exercises on Substack a few days ago, and now here are all the solutions, so I hope that you were able to follow them. And let me know how they went, and also let me know if you have any questions about the solutions, just drop a comment. And if you have any questions about the book or geospatial data science in general, then tune into my webinar next week. Thank you for following and see you later this week, hopefully. Bye.